Hello viewers, I'm Kausalya. Today we are going to solve problem 4 and the problem is for the given bridged T network find the driving point admittance Y11 and transfer admittance Y21 with a 2 ohm load resistor connected across port 2. So here this is the given diagram and we are expected to find the value of Y11 and Y21. So now here we are going to use mesh method. So how many loops do we have here? We have totally 3 loops. Okay. This is one loop, this is one loop and this is another loop. And we have 2 ports. 1 dash is input port and 2 dash is the respective output port. So the modified circuit is that is writing everything in terms of S. So here the value of resistors are 1, 1 and 2 and here it is we have a capacitor of value 1 farad. So here it is 1 by S and again 1 by S. And we have taken the direction of currents. So here it is I1, here it is I2 and here it is I3. So here the output port is short circuited. So this is indicated by drawing a line like this. Okay, this output port is short circuited. What does this mean? That is the value of V2 is 0. So now we are going to write the loop equations. So again in the first loop, what is the value? The net value here is of admittance is 1 plus 1 by S. And in second loop it is again 1 plus 1 by S. Always keep it in mind, that is we short circuited this port, therefore this 2 ohm won't come into picture. So here the value is, you see, for this second loop the value of the admittance is 1 plus 1 by S, sorry, impedance, okay, 1 plus 1 by S. And when you look at the third loop here, 1 plus 1 plus 1 by S, so it is 2 plus 1 by S. And now we are going to write the common elements. So between loop 1 and 2, what is the element which is present? Here we have 1 by S. And now we have to look at the direction of current. I1 flows through this capacitor like this. And similarly I2 also flows through this capacitor in the same way. Therefore here the value is 1 by S and here it is 1 by S. And when you look at the loop 1 and 3. So in loop 1 and 3, what is the element which is common? This 1 ohm is common. So here when you look at the current that flows through this loop 1, here it flows like this, right? It flows like this. But whereas I3 flows in the opposite direction. Therefore here we have to introduce a minus sign. So minus 1 and here minus 1. Now we are going to look at the element which is common for loop 2 and loop 3. So this is your loop 3 and this is your loop 2. So the common element is 1 ohm. So when you look at the value of I2 flows through this 1 ohm like this, and similarly I3 also flows in the same way. Therefore here we are simply writing it as 1 and 1. So this is your value of impedance. So impedance multiplied by the currents. So the respective currents flowing through the 3 loops are I1, I2 and I3. And what is the respective value of voltages? Here we have V1. So V1, and in the second loop and third loop there are no source voltages, therefore it is 0. So this is the basic matrix which you have to write it correctly. Once this is done, then we can easily find out the values of admittances. So first we start with calculating the value of del. So you see, this is your impedance matrix and this is your current matrix, and here we are having the voltage. So V is equal to IZ. So first we start with calculating del. Del is nothing but finding the determinant of the impedance values. So here I believe again you people know how to take the values, right? That is how to take the value of delta, because we have solved n number of problems. Anyhow, let me explain. So here you have to take this as plus, minus and plus. So here the first element is 1 plus 1 by S. So just write it as such and you have to eliminate, okay? We have to neglect this row, that is this column and this row. So the remaining terms are you have to multiply 1 plus 1 by S into 2 plus 1 by S. Minus of 1 into 1 gives minus 1. Now we are going to take this part. So here it is minus 1 by s. So minus 1 by s, again you have to leave this column and you have to leave this row. So you have to multiply 1 by s into 2 plus 1 by s minus of minus 1 into 1. So that makes plus 1. And for the last term, again this is minus into plus, therefore minus. So minus 1 into, you have to leave this column and this row. So while writing, you have to write, you see 1 by s into 1 is 1 by s minus of minus 1 into 1 plus 1 by s. So whenever it is multiplied by minus 1, here what happens? This becomes minus 1 minus 1 by s. So this is what I had written, minus 1 minus 1 by s. Now we have to solve this. So when you solve, you see I had written the equation. Now we are going to solve. So how to solve here? You see, you have to multiply these two elements. So when you multiply, we are ending up with the answer like this, and here this minus 1 minus 1. And here also again we are multiplying these two elements. So 1 by s into 2, 2 by s, and here again 1 by s into 1 by s, that makes 1 by s square. Right. So here just we are doing a multiplication. 2 into 1 by s, 2 by s plus. So when you multiply, you see 1 by s into 2, 2 by s, and 1 by s into 1 by s makes 1 by s square, and this plus 1. And here again minus 1. Here I had just removed the bracket. 1 by s plus 1 plus 1 by s. So now the next thing is, again and again we are going to multiply and we are going to simplify the terms. That's it. So here you see this, in this thing we have two s terms, right? So 2 by s plus 1 by s makes 3 by s. And here 2 minus 1 becomes 1. So 1 plus 3 by s, and this 1 by s square as such. So minus, again I am multiplying this 1 by s with the terms here. So when you multiply these two, what it gives? 2 by s square. Here we have minus, so minus. So again minus 1 by s into 1 by s square becomes minus 1 by s cube. And again minus 1 by s into 1 becomes minus 1 by s. So again here when you move this minus sign inside, it becomes minus 1 by s, minus 1 and minus 1 by s. So here next, I am going to multiply this term with the elements here. So again it gives a big number, and here I had written the same things. Okay, I didn't change anything. I had written as such the same terms. Now we are going to simplify it further. So here you see my 1 by s cube and minus 1 by s cube, they cancel each other, and this 1 and minus 1 again they cancel. So here we have 4 by s square and minus 2 by s square. So 4 minus 2 gives 2. Therefore here it is 2 by s square. And 4 by s minus 3 by s gives 1 by s. So again when you take LCM, here the denominator will be s square, right? So we are going to multiply by s. So here 2 plus s by s square is the value of del. Now we are going to find the value of del 1. So here del 1 is nothing but we are going to replace the first column by the respective voltage sources. So here this is your value of del 1. Sorry, here we should be having determinant, okay, not matrix. Now we are going to find a value. Again the same thing you see here. V1, you have to leave this column and this row and you have to multiply. So 1 plus 1 by s into 2 plus 1 by s minus of 1 into 1. And again when you took the second term, here it is minus 1 by s. You see here we have zeros. 0, right? You will be leaving this column and this row. So 0 multiplied by anything, finally 0. And again for this minus 1 also, when you leave this column and this row, here again we are going to multiply with 0. So it is 0. So we have to simplify only this term. So again when you multiply 1 into 2, 2, and 1 by s into 2, 2 by s. And when you multiply by 1 by s, 1 into 1 by s, 1 by s, and 1 by s into 1 by s, 1 by s square, this minus 1. So here when you simplify, you see we will be getting V1 into here 1 by s square plus 2 by s plus 1 by s, 3 by s, and 2 minus 1 will gives you 1. And again when you take LCM, here the denominator is s square. So 1 plus, here we are going to multiply by s, right? So because we have to make the denominator as s square. So 1 plus 3s, and here you have to multiply it by s square. So 1 plus 3s plus s square by s square is your v1. Now here value of I1 is nothing but del 1 by del. So we know the value, so just substitute it. So here you see we are having I1 in the form of V1. But what we actually need, we need Y11. So Y11 is nothing but I1 by V1. So I am bringing this V1 to the left hand side. So I1 by V1 gives you this. So this is the value of Y11. Right. Now we are going to calculate the next term Y21. So for that we are going to find del 2. So how to find del 2? Again you have to replace the second column by the respective voltage sources. So here this is the determinant form. Again when you simplify here 1 plus 1 by s, here both the terms are zeros, so here it is 0. So here minus v1, because this should be taken with plus sign, this should be taken with minus, and this should be with plus. So when you took minus v1, this column and this row gets eliminated. So 1 by s into 2 plus 1 by s, minus of minus 1 into 1. Plus again plus into minus becomes minus, so minus 1. Again when you leave this column and this row, we have zeros. When multiplied it becomes 0. So again when you simplify and you take LCM, here the first step is we are just multiplying these two terms. So we are getting this, and the next step is we are taking LCM. So here this is the equation, okay, del 2 is equal to minus V1 in terms of this term. So what is I2? I2 is nothing but del 2 by del. We know what is del 2 and del, so just substitute the values. Once you substitute, you see here we get I2 is equal to minus V1 into this term. What we actually need, we need I2 by V1. So here just I am moving this V1 to the left hand side, therefore I am ending up with the expression like this. So finally what is the value of Y21? It is given by minus of s square plus 2s plus 1 divided by s plus 2. So that's all. If you have any doubt, let me know in the comment section. Thank you.